Okay, I guess we can get started. Good morning, everyone. I'm Marco Varlese, and I'm going to talk to you today about the newly started and bootstrapped SUSE Developer Program. My colleague, Tim Hirnich, is very sorry not to be here today, so I will be the only one presenting you the program. Just before I go through the slides, I would like to know and ask, who is in the room a developer? Great. Okay. Just so that I can pitch this in a specific way. So let's start. And I would like to start with why developers are important for SUSE, if it wasn't already very clear. So first of all, developers these days are becoming increasingly a scarce human resource, despite the fact that there are studies saying that there are like 25 million developers worldwide. We still see a lot of need for developers these days. And why? Why? Because the complexity of tools, technologies in general are very demanding, and more developers are required to accomplish specific goals or specific tasks. The industry, to the need of, to the actual gaps in terms of how complex these tools are, is usually responding with abstractions and automation as if that could solve the problem of not having enough human resources. And also what we see is that it's getting more and more common for developers to really focus on what we call the middlewares or the glue layers in big stacks. So developers are spending more and more time sticking things together, making sure that things can work together. And for example, a very good example in this case is the microservice architecture, where you have very small, tiny bits of applications that need to communicate with each other, and so now you have new API that needs to be exported, maintained, and updated. All that requires humans and work. And also, there is a trend where a lot of applications, tools, technologies in general are being moved to the cloud. And obviously, a lot of the clouds out there are running on Linux. So we need to look into how developers can leverage Linux into the cloud. And there are new tools and IDEs that, for example, can be run in the cloud these days rather than running on a standalone machine as we used to do for ages. And an example could be, for example, the Eclipse Shea IDE, where instead of running the IDE on your machine, you could host it somewhere in the cloud with plenty of benefits to developers and also to who has to maintain, for example, an ecosystem or an environment for developers. So SUSE, a couple of months ago, decided to invest consciously into developers and to basically bootstrap the SUSE Developer Program. What we want to basically do is to build communities around the SUSE and our products and make sure that we can drive a superior developer experience across our entire portfolio. What that means is for developers writing C, C++, up to Go, Java, Python, Rust, Lua, whatever type of language a developer uses, we would like to make sure that he can use it at his best. The three people that are part of the core team are Ferenc Zekeli, who's in the room here, and it's our colleague from SUSE, myself, and Tim Hirnich, as I said, couldn't be here today, and he is our program manager, so looking after all the different activities that this program implies. Myself, I'm the architect, so looking at specifically how to make sure that we can build and integrate these tools efficiently in a maintainable way going forward on SUSE products. And Ferenc, again, is also program manager, product manager for all the tool chains, and so managing all this very vast and complex environment. One thing I wanted to say, a bit of advertisement. We are hosting a developer zone area here at the showcase. It's in the corner, in the back of the room. We have lots of activities running throughout the week. We have demos. We have a very comfy area where you can sit and come talk to us, but also come talk to the experts that are running, for example, demos or presentations at our area. So if you would like to know more or talk to us more, just come to our comfy area and we can have a talk. Yes. So as I said, we have a Gardener demo that I think is actually ongoing. Throughout the 3 days, we have different times representing, for example, the NFV stack, something that we put together as a showcase for running an NFV stack on SUSE products with specific requirements, for example, real time, or requirements that are very common to both data centers and telcos, like live patching. So this is a very interesting demo. Unfortunately, here is just recorded on video because it requires a lot of different machines. But we can talk through the demo, what we basically did and how we put it together. There's another colleague, his name is Alessandro Festa. He's looking after the AI and GPUs inside SUSE. And again, he's also there to meet and talk about machine learning, deep learning, tools like TensorFlow, Caffe that are very common in those environments and how we're thinking to move those forwards. And last but not least, Ferenc is going to also have a talk around OpenFuzz and obviously talk more about OpenFuzz at the DevZone. So again, please come and visit us. There are also very interesting demos with 3D printing trains that are being moved by containers. It's all very cool. It's very developer oriented, so it's good. So I would like to talk to you about something that we basically started with because it was obviously a need for us to understand who are the developers that we are talking to and what are their needs. And in fact, we conducted this study looking at the various personas or constituencies that we have out there. And not surprisingly, this study finished with a pretty big number of different developers. We identified 19 personas who have very different needs, and obviously they use very different tools. At the same time, because the 19 constituencies were way too many to be managed and addressed by the program, we looked at how we could combine some of them based on possible common needs or common tools used. And basically, what we ended up with are aggregated categories, where each category basically combines few multiple personas, and where each persona is nothing else than a specialization of a much bigger use case. What happens by doing this abstraction is that we ended up with 6, if I can, 1, 2, 3, 4, yes, 6 macro categories. One being what we call the generalist category. In this area, basically, the people like desktop developers, or people that, because of needs, they tend to do a lot of many different aspects of application development. Like someone that, for example, does a little bit of a UI, but that is not a UI expert, but needs to basically interact maybe with a database to show some data that's coming from a backend. Or, yes, mostly people that are doing this sort of applications that are also obviously also very, very common across various industries. Another aggregated category is obviously the IoT. And in this category, we basically find all those embedded developers, but that also have an eye on networking and security to accomplish all the IoT needs. Then we have another category, which is the graphics one. And in here, we basically have, as subcases, the game developers, the CAD developers, or the developers that are, for example, writing application just for graphics editing. The web is another one, pretty big as well, where we basically can imagine all the front-end development that's going on, or also the back-end developer for web-specific, like, for example, Node.js or AngularJS. Another category which is also growing rapidly these days is the scientific category. And in here, we basically find developers that have to do with machine learning, deep learning, AI. I was reading an article about trends in the industry, and in 2018, the data scientist category grew of 270%, which is pretty huge. And it's not a surprise if you see in how many new environments and ecosystems AI is being used for different purposes, and so the trend for sure is keep growing. And finally, the DevOps. I like the idea to have this as sort of standalone category rather than spanning it across the rest, mainly because what I'm kind of looking at here are people that do mainly two things. One is developing possibly glue layers for various different applications, different levels to basically communicate, and another one is testing, automation testing, building pipelines to make sure that, for example, the CI/CD can keep working. All the fancy technologies and tools that everybody uses these days to make sure that applications can keep being built, and if you have troubles, you can know before it goes to production. So how does the spread looks like? Well, the generalist is still like the biggest area of all, with 35% in our case, in our analysis. The data scientists cover almost the 30% of the pie, with 29%. And again, I'm pretty confident this will be much bigger next year. The web is at 11%, together with the IoT and DevOps at 9%, and finally the graphics at 8%. Something that has to be said, this analysis and this research was basically conducted on what Linux OS is being used and the tools that are available on Linux. So they might be a little bit slightly different if you think about other OSs. So in terms of where the program stands these days, well, we conducted this study and we made sure that basically it reflects the reality. We had very good conversation also with analysts where feedback were provided to us. And yes, some people call different personas in different ways, but eventually the meaning is the same. One thing, for example, that I learned is these days we have two big categories. One is what we call the full-time software developer, and another category that's called part-time. And it's not because you work 8 hours or 4 hours a day. It's mostly because your daily job is to produce software as your first requirement, versus somebody that writes software because he needs it to accomplish something else. And for example, the data scientist is an example where people do write software, and possibly lots of software, but the writing of an application is because they want to get something different out of it. It's not like somebody that's writing, for example, kernel code because he needs to make sure that the machine works, or a driver because the network card has to work. In their case, very likely, those guys are not computer scientists, do not have a computer science background. Most, for example, could be biochemistry or doctors, medicine, that learn to write codes to help them accomplish certain goals in their professional lives. And for them, have for example, tool chains or an environment that is very easy to use is obviously very, very important, because they do not have all the knowledge or skills to spend time on a machine debugging a software issue because something is not compiling, right? For them, it's obviously their first impression, and user experience is a win situation. So in that regards, we know what we have to basically tackle, and we're trying to work also on the budgeting and staffing, because as you can imagine, trying to target 19 different developers needs is a huge set of tools and technologies and frameworks. Personally speaking, we had worked on a document that basically lists all these technologies, and it's 80 pages worth of Word document with all these technologies listed and how they're used, how they interact and intersect with each other. Trying to come up even with a feeling for a priority on these tools is very, very hard these days, because every day, if you keep an eye on the trends of technologies, today you hear about A, and tomorrow will be B, and by the end of the week, possibly it's Z. So there are lots of new tools being produced every day. And there's also the trend where people, because they're curious about new things, they just jump on the next one and on the next one. And so it's really, really hard to make sure that one technology is the better compared to the other. Yes?
Do you publish those surveys? Because it'd be very helpful for us to know what are the popular tools for this trend.
I don't know if we plan to publish that document. I don't see why not, to be honest with you. So my feedback would be, I don't see why not. I possibly would require some polishing. Yes. But yes, absolutely. I take that feedback, and I'll make sure to work with our documentation team to make something out of it. Yes, thank you. So with regards to the variety of tools, we are trying to basically work also, for example, with Alessandro, who's our newly hired program manager for machine learning, to make sure that what the analysis that we did, if it's really in line with what the machine learning AI world is expecting. And another interesting aspect also has to do with the blockchain, right? I think it was just said during the keynote that blockchain is not just like a financial tool, and it's true. Many people know it because of bitcoins and trying to make money out of this world, but it's being used in many different ways. And for example, just the other day I was reading an article about how to make a voting system, like an election system through blockchain. It's going to be used many different places, and
I mean, it's a data structure.
yes.
It's a distributed encrypted data structure. Why
Yes.
should it be, tied to an application?
It isn't.
I know, but why it should be?
Who says that? I think it's mostly not necessarily a developer's sense, but it's what the usual people, common sense.
Application, but I mean,
Yeah. I think what people feel is that when they hear about Bitcoin, they make a correlation between the technology and the use case. But the technology is one thing, and there are thousands of use cases that you can deploy to.
You hear about hash maps, they think it's something to smoke, it's always hard because people think.
Yeah, I think, so if you ask me, I think it's down to us to make sure that people really understand the technologies, right? So I'm trying to be an evangelist of a technology and trying to make people understand when we speak about something, you shouldn't make mistakes about the understanding, right? So I'll try to make sure that people understand what we're talking about. I think it's just because of the first use case that was being used was really tied to the financial and market. People stick with it. And now that,
You're referring to non-technical people, right?
yes,
Yeah,
yes.
That's our problem because this IT technology is so coming in every mouth that everybody has an idea about it. But
Yes. Yeah.
It's kind of like door handles, doorknobs. Everybody uses them. And most people don't care about how it works. They just want it to work.
Imagine the engineers who constructed those.
We want to know what's
What kind of
inside.
discussions
Yeah.
they had.
We want to know what's inside and how we can improve it or what we can do to make it better.
but the problem is that door handles are not that popular as IT technology nowadays.
Well,
Sure,
sure.
everybody
No,
knows about
well,
it.
no, they're not. I'm just using that as an
Every
example.
movies about hackers, everybody, it's so overpopulated. It's popular at the moment, IT. kind of.
Yes, yes.
That's the problem. Everybody reads about it, but door handles are not that popular. Right?
Well, yeah, but there are people who, I forgot what I was going to say.
All
No problem, I forgot.
all,
I know what you mean.
all I would like to say is that we as technologists, I think we have the responsibility to make sure that technology is understood also by those that are not technologists.
But it's very hard.
And so that basically the use cases can be expanded because blockchain is so powerful, right?
Yeah, but if you talk about blockchain, if you talk about money, it's more easy to bring it to people's mind if you talk about money than about the data structure. Data structure, people block. They
Yeah.
don't want to hear about data structures, but they want to hear about a new financial system. So that's easier to get in their minds, But actually, it's a data structure. It's a distributed, encrypted data structure. Period.
Yes.
Whatever you do with it.
Yes.
Whatever you apply it to it.
Yes.
But to read about encrypted, distributed data structures, people won't read the article. Or
They just totally blank out.
I totally,
Yeah.
Let's go back to
The
the
doorknob,
doorknob.
no. I don't want to get much more.
I totally-
I just want to know it
But
works.
if you talk about the new financial system which brings the new wealth to everybody, then it's easier to bring to people's mind.
yes. And I totally agree with you that the communication needs to happen in an easy way for people to understand it. All I'm trying to say is that making sure that new use cases can be embraced. For example, like the research in molecular, analysis, etc. Blockchain is a very good example there, right? Because it keeps your privacy. There is no data that you can break, etc. So, it's just like making sure that the use cases can be understood by people that are not technologists. Right?
So we need to develop a different language for people who are not technologists. The language we need to use is separate from what we use in ourselves.
Yes, and that's exactly one thing that we, with the developer program, are also trying to tackle. Because me, as a technologist and a developer, I obviously have a language that other technologies can understand, but if I try to explain something in the same way to somebody that comes from biology background, probably won't understand anything. And this is something that we also are trying to address, where wording and explaining things in an easy way for others that are not technologists is also very, very important. Because otherwise we would only address a specific type of developer, right? And as I said, we have like 19 constituencies.
In the language of technology, it's hard to stick to the point, because it's not easy. It's to explain blockchain on a non-technical basis. Go ahead. It's hard, right?
Yeah, it's difficult. It's
Everybody
impossible.
everybody tries, and then you read very absurd articles. That's the result of it. If you leave the technological language, right?
I think like it could be also something similar to what the machine learning, for example, has been for many, many years. But some things require quite a bit of time to also be digested. So blockchain is very new, and it's like literally the bleeding edge these days. So it will take time.
Wouldn't it, for most people, be behind the scenes and you would never even know what was happening? I mean,
Yeah.
If you're using it, you're using blockchain, or if you're using a database or MySQL or something else, they don't know what they're using.
Yes.
They just know that when they hit the button, it comes up with the information.
Yes, but it's also, I see this trend pretty much in every new technology. Like somebody that has been using relational database for all his life, using SQL, and then one day in the early 2000s, somebody says no SQL, right? And everybody was a little bit skeptical, trying to figure out how these things work. But now, everybody's very, very familiar with the concept of NoSQL and the difference between that and a relational database, et cetera, et cetera. So it's just a matter of waiting and making sure that the word can be evangelized more, right? And technology being used. So what we have as future steps, well, we are in the phase to basically prioritize those items that we have identified. So to go back to your point about those 70 pages document, we're working with product marketing, product management, strategies, and all various stakeholders inside SUSE to make sure that we can identify what's needed today and what's needed tomorrow. And we're also working with various people inside SUSE and externally to make sure that we can have a portal for us to receive feedback from people from the outside. We're thinking about setting up a web portal where people can directly get in touch with us, but that can also, for example, leverage information that we provide in either an horizontal fashion or vertical use case to learn about specific technology. So, for example, again, if you think about the machine learning, that's pretty much a vertical. All the technologies that are part of a machine learning use case, how they are deployed, how they're used, how they interact, what about GPU's acceleration for AI, and all that. So having a structure that allows us to communicate to you and get feedback. And also, we would like to very soon start a contributor-based engagement. So basically, getting people from outside SUSE to contribute documentation, material code, examples application, web binders, anything, training that can help other developers with the path to develop an application for a specific use case. I cannot be the expert around 19 different use cases and around hundreds of technologies. It's literally impossible. I'm a network software engineer myself, so all my background is in a specific use case. But let me tell you about what is ongoing today with engineering in SUSE. We are building a Go ecosystem that basically helps developers that are packagers in SUSE or future packages for Go application to have an easy life with Go. Go is very powerful, but it's also has some wrinkles whereby if you need to package your application in, for example, in an RPM to make it available for SUSE distributions, SUSE products, you may have a little bit of problems. Why is that? Because Go pulls codes from the internet to basically build the dependency that's requiring. And that makes packaging very hard, because what we want to make sure is that a package can be always tracked to a specific source code in order to make sure that we can know what has been built, when, and how. In case, for example, a security vulnerability is being issued, we would need to know what is being shipped in our products to make sure that we can address those security vulnerabilities. And now with Go, all of a sudden you may have 10 packages that are using 10 different versions of the same Go library, just because of the way that the Go mod allows you to do things. And there's an engineer in SUSE, his name is Jeff Kowalczyk, and he's reporting to Scott Reeves here in the room, that's basically working to make sure that our open build system, OBS, can basically support this need, can basically make sure that dependencies can be tracked and that the pool of this code happens from somehow from a more secure or well-trusted URL. Another thing that we are tackling is the Java ecosystem. Java, in the analysis that we conducted, it's very, very well spread and very used throughout the industry. And it's not a big surprise. But one wrinkle with it is the Maven Gradle ecosystem that Java uses to basically pull specific libraries, again, from the internet to build a new application. What that means, again, for people like SUSE or for people that are doing packaging is that you cannot know what package you're pulling because the jar is a binary. So you'll start facing issues about what am I shipping and who built these binaries, and what if somebody put something in it that is not a good thing? What if somebody put a backdoor in the jar, right? You cannot know because it's a binary. And we are addressing this need for packagers and for security reasons. How? We are basically built an environment that can be bootstrapped and build Maven on its own. One of the interesting thing about Maven is that it's building its own. So it's sort of circle dependency. It can build itself. So it required a little bit of an effort to make sure that we can build its own OBS. But also, what that means is that now we can have dependencies of jars within OBS and build jars ourselves. So, for example, get again a tarball, a source of a specific jar, and build that jar on OBS. And any application that requires that jar binary, now instead of taking it from whatever URL on the internet, it can use our own repos, which basically means we know what we are building, people know what we are building, and we know where we're taking it from. Again, security, reproducibility, all the good things about having a package. And last but not least, a very important thing for everyone that's working in the open source communities, upstream communities, Vagrant. Vagrant has been around for a while, and it's a very efficient, easy way to basically have a virtual machine bootstraps in a few minutes. People basically provide virtual boxes on Vagrant for others to be used. You basically bootstrap your machine in 3 commands. Why it's so important? It's important because we are upstream first people. We want to make sure that people that write software that then we basically use on our distribution can also have an easy life building software on SUSE products. And so we basically started this activity with another engineer, it's called Dan, to basically create in an automatic fashion background images for all our products, our portfolio, so that basically a developer now can do background up, gets our OpenSUSE tumbleweed image or leap image or SLES, and boom, use it to build code, test code directly as if it was an open, a SUSE product. It's very, very valuable. And beside that, background VirtualBox images, for example, they are integrated in CI/CD pipelines of various upstream projects. So what that means is someone like myself who was part of very different communities upstream now can basically test the code, not necessarily on a machine in the lab, but can have the CI/CD pipeline upstream running it and doing test validation, and finally, first, thumbs up for the build. It's very, very powerful and really needed for developers out there. So finally, a little bit of takeaways. Developers are really getting more and more influence also on decisions that are being carried in companies, in the industry about what technology to be used. So they're gaining more and more credibility within the company, also with all the Cs about which technology shall be used in the future. So not listening to a developer might be dangerous. And it's somewhat is nothing crazy, because developers are really the ones that are super close to the technology, that really understand how the technology works, so they shall be heard. As I said, SUSE is driving really a conscious investment in making sure that we can build communities around our product portfolio for developers and offer a superior developer experience on those. Again, please come meet Ferenc, myself, and others at the DevZone. We have plenty of things running. And most importantly, we are very open to listen. Just be open and tell us what you need, what would you like to see on our products, how would you like to use your technologies, your tool chains on SUSE products. We really, really need your feedback and input to make sure that we can do the best and make the best out of it. And with that, thank you very much. And if you have any questions, please ask. Yes?
You focus on Go, Java, Vagrant. What about the infrastructure and network guys that use a lot of Python or Ansible or Puppet? Is there plans for integration with that, which will bridge the gap between legacy and new emerging technologies?
Yes. So the straight answer, yes. So Ansible is the technology that these days everybody uses to glue all the infrastructure. And that's captured under the DevOps area that I had before. Again, even in that context, there are many different things and many different tools that can be used. So we are in the process of doing the prioritization of those, but from a use case perspective, absolutely, that's very big. And it's almost like a niche within the bigger use case of the low-code, no-code developer, where people really spend 8 hours a day trying to figure out how to make things sticking together, and then possibly you write 3 lines of new code just to make it working. So basically, it's a lot of research and trying things out, and then Ansible is definitely like a very important tool to be used, or language. Thank you. I think I'm right on time. So thank you. Thank you very much for your time.